Hello friends, in our previous video we had talked about the amino terminal, carboxy terminal in a peptide chain. So in continuation of that, as another concept, we'll be talking about what is the Zwitter ionic form in an amino acid. So for us to understand that, first we need to know the basic structure of an amino acid. So let's have it here. C, COOH, NH2H, and this is going to be R. So this is basically a structure of a amino acid. So everyone should be aware of this. Friends, this is basically in an unionized form or an undissociated form. Okay, so in case if this gets ionized, so what happens here is this become COO minus NH3 plus. See, you have a chemistry behind getting this NH3 plus, like lone pair electron, etc., etc. Okay, I'm not getting deeper into that. Okay, but this is how it is, and you have an H and you have got an R. So this is the ionized form. Okay, and this is the unionized form. Friends, if I'm going to mass this amino group, if I'm going to look at this amino acid, right, what I see is a negative charge sitting there. So I claim that the amino acid is going to be negative charge. Likewise, I'm going to mass this, mass this, and look at the charge of the amino acid. This is going to have the positive charge. So I can claim that the amino acid is going to be positively charged. But on the whole, this amino acid has got both the positive charge, which contribute, say +1 is going to contribute -1, and these two are getting neutralized by the presence of the either positively and negatively charged. So net charge is going to be, net charge is going to be 0. So this form of amino acid, where the net charge is 0, where the net charge 0, amino acid being ionized, that is having both the positive group as well as the negative group, which gets cancelled or which gets neutralized, bringing the net charge to 0, this referred as a Zwitter ionic form. You get this point? You get the thing called as Zwitter ionic form, or we can also call this as an ampholyte. Also call this as an ampholyte. So this is what is Zwitter ionic form is. Hope things are clear. So in understanding what Zwitter ionic form is, let's get into one more interesting concept called as isoelectric pH or isoelectric point. So what is this isoelectric pH or isoelectric point? Fine. So friends, we all know from our basic chemistry that the pH can range from 1 to 7 to 14, and this is the neutral pH. This is of bit alkaline, and this side is of bit, this is an alkaline side, and this is of bit acidic side. So we know quite know about the pH range. Friends, an amino acid will behave as Zwitter ion in a pH from 1 to 14, any particular pH only from 1 to 14, not in all pH. And usually we get confused that that pH should be necessarily 7, need not. That pH is determined by the nature of the R group. So we know that the R group is going to vary between the 20 amino acids what we see. So based on the nature of R group, that particular pH at which the amino acid behave as Zwitter ion will vary. Hope you get my point. So that particular pH, is what is referred as a isoelectric pH or isoelectric point. It is the pH at which the amino acid behave as a Zwitter ionic form. So again, that depends on the R group, and it is going to be the signature and constant for an amino acid. It won't vary. Any amino acid, generally at that particular isoelectric pH, it will behave as a Zwitter ionic form where the net charge is going to be completely 0. So we have understood two concepts. One is what is Zwitter ionic form and what is isoelectric pH, right? And one more thing to add, let's assume that an amino acid A1 has got an isoelectric pH of say 5.0. So what happens if I'm going to bring down the pH? Bring down the pH. How will the amino acid considered here will behave at 5.0, being then isoelectric point, this behave as Zwitter ionic form. What is that if the pH is brought down, say 4 or 3, what happens? So So for us to bring down the pH, what we generally add acid, and the reason acid bringing down the pH is it is going to increase the number of H plus ion, proton, right? So basic chemistry. So when you keep adding the or increasing the number of proton, what happens is this proton is going to interact with the COO minus. Okay, so this becomes COOH. Okay, so what happens? This becomes, okay, rather than having a charge, this becomes neutralized. So your amino acid will have only this particular amino charge, there is a positive charge. Hence, you get a cationic form. So, amino acid behave as a cation when we bring down the pH from isoelectric point or isoelectric pH, right? The other way, what happens if we are going to increase the pH from the isoelectric pH, right, towards the other side? What happens is, we keep adding OH minus, the OH minus will get attracted towards the positive charge of the amino group, right? So this become neutralized and it has only the negative charge of the COO minus. So it behave as a, okay, anion. Okay. So these are all the basic concepts that we are supposed to understand for us to solve some, okay, questions that comes in biomolecule chapter in some of our competitive exam like NEET, okay, or other biology based competitive exam. So hope things are clear. To summarize, okay, today we have talked about what is zwitterionic form is, what isoelectric pH is, and how an amino acid is going to behave if you bring down the pH, okay, from the isoelectric pH, or if you are going to increase the pH away from the isoelectric pH, right? So hope things are clear. Let's meet in another interesting discussion. Okay, thank you.